In Lesson 5.2, we'll understand the life cycle of a process. So we talked about fork just a minute ago and how it's a system call that clones a process. So the moment that the process is cloned, the memory and the code of the clone is identical to that of its parent. The new process, the forked process, receives a return code of 0. So it checks its return code when making the system call, and if it receives return code 0, then it knows I'm the child process. And this is really just this is information necessary for a programmer who's writing software that clones out new processes, forks new processes. The original process, the parent, receives the PID, the PID, of the new process as its return code. In this way, the parent process can keep track of all of the other processes that it's cloned because it knows what their process ID is through the return code. And then for the child process to start execution of a new program, it calls the exec system call. There are a number of process states, and the kernel maintains this map of process states. The first process state is that of runnable. A process is ready to be executed. In addition, there's sleeping, where a process is waiting for some resource. So it doesn't have anything to do. It's waiting for disk, or it's waiting to load something out of memory, or it's waiting to receive data from the network. CPUs are, of course, very, very fast. And so the time it takes to execute code is extremely fast in comparison to the time it takes to retrieve something from memory or even to go all the way out to disk. That takes a really long time. So during that time, the kernel doesn't want to waste cycles loading that process, having it do nothing, so it puts it in the sleeping state. There's a process state known as zombie, and this is a strange state where a child process has terminated execution. It's quit for whatever reason. And the parent process hasn't yet reclaimed that process. It hasn't reaped the child process. So that's known as a zombie state. It doesn't happen very frequently. It usually indicates some kind of a problem. And then finally there's stopped, which is a state known as administratively forbidden to run. It means that the administrator or the kernel has stopped execution of that process for some reason. Maybe just for intervention or for whatever reason that process shouldn't be running. So let's take a look at what this might look like on the command line. I'm logged into my CentOS box here. First thing, let's look at the process tree using the pstree command -h. So here we can see the very first process, the parent of all processes, init. Init has cloned itself into a number of other processes, and you can see that in this tree hierarchy. Init is the master daemon, and it spins up all other processes. So we can kind of scroll our way down here, and we can see that this tree where SSHD is. We see a number of SSHD processes, followed by bash, followed by pstree, the very command that I just ran. So let's explore this in a little more detail. Bash has an environment variable, a built-in environment variable called bash PID. This is the process ID of the current bash shell, my logged in shell that I'm using right now. So I can use the ps command to check out this bash PID, and I can see what its parent PID is, right? The parent process ID would be the parent process of this current bash PID. So the parent process of my current bash shell is 1892. And I can keep following this tree all the way back. So now I'll repeat the same command, only I'm substituting my parent processes, which we just discovered. And we should be able to trace this back all the way to init. So at this point we're right about here. We're following each process back up to its parent. So now I'll look at 1891 and 1889. I'm now looking at SSHD, and that cloned, these are all just process IDs in the process table. And so we finally got to 1. 1 is, of course, the process ID that's always assigned to init. And so in this way, we started here with our bash shell and traced each parent process up the tree back to the init daemon. That's all for understanding what the life cycle of a process is all about.